Okay, welcome to our session today. We had a failed attempt. We had many failed attempts to communicate through Teams. We tried then with Blackboard, and then we tried with Skype. Yeah. So the solution was that I will record this video for you, and then you have to watch it, and then you have to bring questions, if any, on Friday. Okay, and then on Friday we try again with one of these marvelous tools for online lecturing. Okay, so just to give a quick recap of what we have done last lecture. So we started to talk about offshore structures for oil and gas production. Here we are excluding the structures or floaters or that are used for drilling, exploration, and production wells. We first went through all the components that are included in usually included in an offshore structure. The offshore structure doesn't have to have all of these components, but these are all the components that are the most relevant for an offshore structure to have. Um, yeah. Separation, well bay, offloading. We see how things are arranged on a platform that they can be spread. We talked then that there are two main types. One of them which is bottom supported, and one of them which is floating. Bottom supported, all the load of the structure is transferred to the soil, either by piles, simply by its own weight. And then you have two different variations. One of them is fixed, in which there is no significant movement of the structure, but compliant, it allows some structure, and actually there are some tendons, some wires that are keeping it, limiting that movement. While we have the floating structures in which these structures are floating, are buoyant, and also they are moored typically, and they exhibit significant movement in all directions. Okay, and you have neutrally buoyant, that they control buoyancy with the ballast, depending how much load they have, and also there is one which is positively buoyant, meaning that the TLP tension leg platform is held in place with these tendons, with these tethers, and if they were not in place, it will float up and it will be at a much higher, and it will be unstable, at a much higher position, and it will be unstable. Yeah. So then we went one by one through the main structures. Uh, then one important comment about the FPSO. The FPSO usually has a swivel because in many locations in the world, the sea conditions are changing. The direction of waves are changing with time. So the vessel has to rotate to be aligned on the direction of these waves such that it won't tilt on the side. Um, and that unit is called a swivel. So the swivel is actually anchored in place or is moored in place, and then you have the pipe in the same location, and then the vessel is allowed to rotate around that swivel. Okay, however, if the weather conditions are still, you don't have much variation, then you don't have to use a swivel, and simply bring up the risers on the side of the vessel without any need for any swivel. Okay, we saw some videos how it looks like, and what we mentioned was that swivels can be bottlenecked because they are sized for a particular rate, for example, a liquid rate, and if you have too much water coming in, then you are restricted for that amount of fluid you can circulate. Also, for example, if you have sand production, um, then it's going to be limiting the amount of rate. So it's in an FPSO, the swivel it's an important source of constraints sometimes, of technical constraints. A spar, quite unique, quite deep draft. It's a big part of the structure is submerged, and that gives it some stability. which allows it to be like to reduce movement. There is one in Norway that is called the Ostahansten spar. One thing with spar is that we talked about vortex induced vibration. That if we have to be careful with that because there might be significant forces on the cylinder due to the vortex shedding. Okay, and this vortex shedding is cyclic and is shedding at different locations every time, and then it causes a cyclic force on the structure. Okay, to avoid that, we usually use helical strakes or we use other tricks. Sevan FPSO, which is the same principle as the FPSO, but in that case we just take the swivel, we take the rest out, and then we make it big, such that we have space for all the facilities we need to place. Okay, TLP we have already discussed before, and the principle of TLP, what makes it so stable is that it doesn't have much movement in the vertical direction, but it has some movement in the horizontal direction. But then after it's put out of offset, out of location, then these horizontal forces appear on the tethers, on the tendons that tend to bring it back. So that's why it's like a self-balancing, more or less like a self-balancing structure. Compliant tower, we mentioned it has allowed significant movement, but then you have this mooring, or you have these tendons that keep it in place and restrict a bit the movement. Semi-submersible, used very much for a drilling ship. Then we talk about some criteria that is used to decide on offshore structure, which offshore structure to use. And I told you we have water depth. Okay, that here we see the spread of the different, when are they used, the different structures, and we see jackets and compliant tower, they are limited to low, to shallow depth. Okay, well, shallow it's but to 400, 600 meters, but for example, other structures like TLP, it can go a bit higher to 1500 feet, 1500 meters. Um, yeah, and then you have spar and FPSO, which basically can cover the whole range. Okay. So Christmas tree, depending on, I told you there are two types. They call it platform whales or dry Christmas trees, and subsea whales or wet Christmas trees. And essentially, it depends very much on one of the things is something we cannot control much is the reservoir spread and structure. If we have a reservoir which is very spread, usually it's very expensive, even impossible to drill everything from one location. So we decide to use subsea wells such that we can drill exactly on top of the formation, on top of the reservoir we want to exploit, we want to produce. On top of the unit we want to produce, while if the reservoir is concentrated, we can reach everything from one location, but then we need long deviated wells that might, for that I need a bigger drilling package, okay, and more expensive. But however, here, when we are producing these type of platforms, then because we will have to wait because of safety reasons, because when until all wells are drilled, usually we have like a big ramp up. The ramp up is very short. Okay, while if we have subsea wells, if we have the FPSO and the flow lines and risers in place, we could start to have like some sort of gradual ramp up of production, which is helpful for recovering revenue quicker. That's a comment on the drilling package. Here I made some comment on a comment on the transfer of weight, that regularly in onshore wells you have the conductor, you have surface casing, intermediate, production casing, and all of them are, the weight is being transferred to the soil through the conductor. So you hang each casing, or you hang the liner on the casing, and each one of them is hanged on the previous. In offshore wells, platform wells, and shallow water depth, wells are drilled just like onshore, in which simply I prolong the conductor up and I prolong all the casing strings up. Okay? But when we say that we are for significant water depth, like for example TLPs and spars, then I there is a wellhead which is at the mud line, in which the conductor and most of the casing strings are located, okay, and they are hanged. And then you have a riser that is only hanging where the production tubing is hanging on that riser. Okay. So you have access, you have like a secondary type wellhead where you have just the tubing hanger and then you have the Christmas tree up on the platform. Okay. And the structure is carrying the weight or the structure or the floaters. We will see how are the support structure now, but the weight is being carried um, by the structure. Okay, like in this case, if you have a spar and it's moving up and down, then you have some flotation cans that keep the riser up, and then you have a flexible hose that is connecting the well to the manifold, the production manifold, for example. Okay. We went through this already. There are different support systems. You can read more about it on the slides and on my compendium. And then we said that dry Christmas trees or platform wells is only sparse CLPs and semi-subs that have small enough movement suitable for dry Christmas trees. FPSO, Sevan FPSO don't have small range of movement. Okay. Yeah. Then we went into this part, which is lay out a bit of subsea systems, how wells are arranged in subsea fields. So one way to do it is typically using template wells in which you have a structure, and in each structure you have, in this case, you have 4 slots. You see more or less here each Christmas tree, and you have the cover that you open to make intervention or to drill even the well. And in this case, this is a 4-well template, which is very much in use in the Norwegian continental shelf. And you can have also templates that have more than 4 slots. You have 12 or 8 depending on the preference. You have some, I think in Troll they have more slots. Then the other approach is to use satellite wells, in which the wells are standalone. They are not part of a template. And then you have one central commingling unit a manifold template where you commingle production of all of these. In the previous case, in template wells, you have just one pipe coming out of the template, and you have the manifold someplace in this template. Hmm? While here you have to have the template, the manifold template, whatever is joining the production of merging the production of all these wells is on a different unit. So you can either, if it's close, you can simply connect it with a rigid pipe, which is called a jumper. We are going to see now how it looks like. But if they are far away, you simply use simply a flow line or a pipeline. Okay. The difference is, yeah, that's the jumper. You have vertical connection, okay, and you have, horizontal connection, and you have vertical connection, which for deep waters, vertical connection is preferred usually because it helps, the weight helps to centralize it and put it in place. Okay. There is some similar dilemma like what we had for dry and wet Christmas trees, that with template wells wells are drilled from one location. You can drill 4 from the same location, so the drilling rig doesn't have to move that often. But also wells have to be deviated, which is more costly. And also you don't need all of this equipment to join the well with the manifold, for example. In this case, you have everything compressed in one side, so you don't have to put a flow line, you don't have to install the flow line or install the jumper. While when you have satellite, then you can drill exactly on top of your target. But the main which is makes much simpler and more cheaper wells. But the problem is that the rig has to be mobilized because if they are too far away, then you have to move the vessel to drill, which takes time and it costs money. Also, the subsea equipment, it's more subsea equipment is required, like flow lines, pipeline, manifold, template, jumpers, etc. Then we went into the production manifold, and we went to the case of what happens onshore. And onshore, production manifold is this structure that we draw here that simply commingles the production. Here I'm taking production of well 1 and well 2 to a common header. For that, I usually have a non-return valve or a check valve, and then I have a routing valve that is either open or closed. And then I reach a header, and that header just produces to one separator. Okay. I can have typically on platforms and also onshore, I typically have two separators, or I have separator, production separator and test separator. So then I simply duplicate this arrangement. I have two headers, I have two sets of routing valves for each well. And then, for example, if I want to produce well 1 to separator A, this valve is closed, this valve is open. The same thing with well 2. And so the manifold is this structure, collection of pipes that you have valves and you have headers, piping valves and headers that are simply to commingle the production of wells. That's the main function. They route the well production to a specific separator. For example, you have one separator on the platform. You typically have two production separators, two separator trains. And for example, one of them has too much gas and is reaching the bottleneck point. So then you are able to, with that flexibility, you're able to move production from one gassy well to move it to another separator, which is not constrained, which is not bottleneck. Okay? Another, why do we have manifold is to test wells, and test wells simply to see the government wants to know how much you're producing, also to allocate production, to split between, you have different operators, different owners in the field, so they want to see how much each one is getting, and might be that the reservoir units, they have different ownership, so you want to know how much each reservoir unit or each well is producing. And also for engineering tasks such as quality control of models and improve models. So more in detail, how does the manifold look like when we are subsea? So remember this four-well template. We have um, the slots for four wells. Usually three slots are drilled and one of them is usually left as a spare. And then you have the manifold in the center, and the manifold, if we open up, it looks like that. And simply what we did on the lecture was to try to see how the subsea manifold looks like, which is very similar to the onshore that we described before. We have two headers, and now the wells are located around the manifold. The well has entered with one line, and that line is here. Okay, we don't want to put two pipes because then we need two interface points. Here we have just one, and then inside, if you follow this pipe, it splits, and then you have two routing valves, which are these two here, and they look big because they have the actuator. You don't need, they can be operated with ROV on this side physically, but they are usually operated with hydraulic line. Okay. So then you can decide to produce to header 1 or header 2, and the headers are just here on the base. And yeah, and you have here, usually we will see soon why that's done, but you usually have a valve joining these two headers. Okay, in case it opens, then it will join these two headers, which is, you defeat the purpose a bit of having two separate headers that you can produce to two separate separators, but we will see now why that's in place. Other things you see here, which we are going to discuss a bit later, not in this class, but maybe in a few weeks, is you have all of these kind of color line, blue one, pink, and these are for when you have the hydraulic fluid, chemical injection, you have communications line. Okay, that you need, we will see later, but you need the hydraulic line, you need to operate valves, to open and close valves and chokes. You need the chemical injection line to inject, for example, scale inhibitor and hydrate inhibitor. Um, then you need the communication line if you have any instrumentation on your well, and if you have any instrumentation inside the well, you also need that. Then we have these two valves, which are called the HIPS, High Integrity Pressure Protection System, and these are typically in place because the system downstream from outside of the manifold is made for a low pressure rating. Okay, no, they are not supposed to tolerate. If you close production on the separator, you're not this won't tolerate full reservoir pressure. Okay, that might be 200, 300 bar. Okay. So what you make is you make these pipes that they tolerate much less pressure. Okay, but then you have this safety system in place, in which they are responsible for if they see any overpressure, they see that the pressure of the line, they have some pressure sensors, and they see that the pressure is increasing and getting close to the rating pressure, then simply they close and they protect, like the downstream system. They are made there just to protect the downstream system from the upstream system, which is made for high pressure. Yeah, and you have redundancy, that's why you have two, and you have two lines because you have two headers. Okay. Then the last thing we did was to make some comments on the weight transfer. Remember that the Christmas tree, the well, the Christmas tree, the conductor, all of it is just transferred. The weight is transferred to the soil through the conductor by this what we discussed before, the arrangement of concentric tubulars, concentric casing layers. But and in this case, the weight of the template is carried by these supports, which are usually the suction anchor. Okay, so the whole weight of the whole template and the weight of the manifold is carried by the soil. But what happens if you put a well that was initially shot into production is going to expand, typically a few centimeters, can be to even to half a meter, for example, and then it's going to go up and down. And if you make, while the rest of the system is going to stay in place, is not going to move, because that expansion comes from all the casing layers that are getting warm up. So it's a very long body. The casing is long, and the tubing, long tubulars, and they simply, when they warm up, they stretch. Okay, it's like a beam that is stretching. So so if you have one structure which is fixed and you have one structure which is going up and down, then the connector might, if it's rigid, it might suffer. So that's why you have, for example, you create some elasticity on the system, you create some spring-like behavior on the system, which is this loop, okay, in which if you have some expansion of the well up and down, then this loop can absorb, can have some increase the elasticity of the system and allow for some movement up and down. Well, that was all that we covered during our last lecture, and I just wanted to go a bit more in detail through the last part because we missed part of the recording. So now we go to the topic we had for today, that is to continue our um, our presentation. Okay, yes, I want to give some comments how metering is done offshore. Sorry, onshore. Okay, so one option is what I already mentioned, that you have, let's say that's our well, and then you have our one-way valve, and then we have our routing valve, then we have our first header, okay, and then we need to have, if we're going to make testing, we need to have two headers, and then you send the production of this header to the main separator, and then you send the production of that header to the test separator. That's main, and this is the test. Okay, so whenever you want to put that well in test, you close this valve, open this valve, while the rest you might have here other wells, okay, that are producing to that main header, okay, and the other wells keep producing. Okay, that will be well 2. Okay. We have also other schemes that we could use for when we are onshore. Okay, if I don't have, because in this case you see I need to have my facilities relatively close. Otherwise I need to put two long flow lines or two long pipelines all the way to the facilities, which might be very far away. Okay, so if you want to avoid having to install that line, so then you can have, for example, I'm going to just simply ignore the one-way valve, the check valve. Okay, so you have the test header, okay, and then simply you have a connection in which you can connect a test separator. Okay, and then the production is usually sent back to the main header that goes to the main separator. Okay, but simply you have the same configuration. You have the production manifold, you have the main header, and then you have the test header, and then you have here a place where you can put your test separator. Okay, that can be a fixed installation or it can be portable, that we will see a bit now how it looks like. Okay, and then you simply, that production that you meter, you send it back to the main line. Okay, you see here one of these portable separators that they bring it in truck, they deploy it, put it on this place, on this location, and then you can measure how much you're producing, and then you move to the next path or to the next well. Okay, remember here usually we have other wells. Okay. Another approach is I have a meter. It's already, instead of separating, okay, uh, like in this case a multi-phase meter. Okay, you simply store here a meter. Okay, you don't install a separator. Okay, okay, instead of a test separator. Okay, so you simply add a meter, and usually remember we need to have some valves to isolate, to connect and disconnect that meter, to make service to that meter. But essentially, if I don't need to separate, if I trust my multi-phase meter, for example, also in cases where I have mainly liquid, so those conditions I have mainly for example, oil and water, then I can use with relatively high level of confidence a multi-phase meter. Okay, we already discussed how the test separator looks like. And metering subsea, if we repeat the arrangement we had before, so we have our manifold module. Okay, let's maybe change the color. Okay, our 4-well template. Okay, we have a valve here, then we have another valve here. Okay, so in that case, you can simply connect these two lines. You have these two headers, and you can connect these two lines to the platform. You have here two separators. Okay, and you go to the other separator, which is the test. And that's the main process, what they call the process separator. And all of this here is on the platform. Okay, so it's exactly the same purpose. When I want to test well 1, this will be well 1, I connect to the main production line, and then when I want to produce it, when I want to test it, I close that valve, open this valve, and then produce to the test separator. Okay. If I sometimes I have a multi-phase meter, okay, that is again with the same purpose to, but I have to look for the pen, but with the same purpose, I typically have either on the well I have a multi-phase meter, okay, and then I have, okay, typically I can have the two, but I won't use the two now, I will use just one. The two can be used to split production, okay, to two lines, for example, but not to meter. Okay, in this case I have just one line that goes to my facilities. Okay, all of this is on the platform. Okay, and what we were saying here is that if you have enough funds, if your wells are good producers, then you want to make a multi-phase meter for each well. Okay, or you can have another arrangement. I'm going to put it here with the other well on the other side. Okay, maybe I use this well here. Okay, in which you have, this will be the test header, okay, and that the other one is the production header. So you have a multi-phase meter between these two headers, okay, probably with isolated with check valves. So you have the option to go either to this header, or you go to this header, okay, from well 2 if you have one common meter for all the wells, and then you decide if the well is simply producing, okay, or if not, I put it to the test header, then it flows through from the test header to the production header, and then you can measure how much each producing. And in this arrangement, you can use a common meter for all for all manifold wells. Okay. Okay, let me just change. Okay, before we go to this topic, I just want to make also a comment what happens when you have satellite wells. Okay, let's duplicate, create a new slide here. Okay, here it's multi-phase meter. This is satellite wells. Okay, remember you have the satellite wells and you have then a manifold module. Maybe use a Okay, in the manifold module you have exactly the same arrangement. You have two headers. Okay, and then you have a line coming from well 1, enters into this manifold, and you have the option either to go to this manifold or to this manifold, and then you have a line in which okay, you have a multi-phase meter. And now let me just enclose everything with color. It should be here. And simply you have here the main pipe going to the separator. Okay, so in which you have satellite, you have just one flow line. This can be a jumper. In this case, is connected to this manifold template, and from there, then you can split. You have two headers. You still have the production and the test header. When you want to make it into test, you send it to the test header. Then it goes through the meter and back into the production header. Okay. The next thing is just a comment that metering can really, the need for testing can really have a big impact on the layout of the field. Okay, for example, this is a case in Brazil. They have quite strict regulations for metering. So say, for example, this ANP is a National Agency for Hydrocarbons, similar to the Norwegian Petroleum Directorate that we have in Norway. And they say have a section on testing of wells. Okay. If testing, I will make some translation from Portuguese, attempt to at least, in the case that the results of the well testing are going to be used only for production allocation. Okay, production allocation means to, within the partners, you try to split how much is produced by each well. Okay, each well has to be tested in an interval not more than 90 days. Okay, or any time that some shift from the regular operational conditions are detected. Okay, but however, when the results of the well testing are going to be used um, for fiscal metering, okay, that means to reporting to the government, okay, how much you are producing. It must be tested at least every 42 days, okay, or every time you detect variations in the operational conditions. Okay, but for this case, for you have to use test separators or tank tests to make this testing. Okay, other test methods that use new technologies, they have to be previously approved by the agency. Okay, so that means it's a very strong uh, requirement that you are not accepting this method the multi-phase meter or this method to report production for the offshore fields. Okay, so that means that essentially you need to have either two lines, okay, or you need to have each well must have its separate line to be able to reach the test separator. Okay, maybe I should remove this from here because I don't want to spoil this drawing. Okay, like in this case you have that causes a lot of issues because you have a lot of risers. Each well, for example, each well has its own riser, and then if you have 20 wells, you need to have 20 risers. Okay, unless you can split in one template, you can split and have just two risers for the whole template, but you need to have lines for each one of them because you want to be able to test uh, how much each well is producing. Okay, with a test separator which is on the vessel, which is very expensive. While for Norway, you have a different arrangement, and Norway they say for fiscal purposes, measurement of petroleum for fiscal purposes. Okay, and it says here multi-phase measurement may be used if traditional single-phase measurement of hydrocarbon is not possible for financial reasons. Okay, the multi-phase meter then can be used as a fiscal meter. Okay, that means what we were saying before, the Brazilians, they don't accept, has to use a test separator, so you have to take the production of that well to surface, while Norwegians, they say, well, in case it is going to impact negatively the economy of your field, then you can use a multi-phase meter, and then you can use it as a fiscal meter. However, they give the details about that meter has to be calibrated against the test separator or other reference. Okay, okay, let's talk about pigging. Um, and pigging, so what do we mean by pigging? So if we have our flow line, okay, or our pipeline, pigging is something that also affects significantly the layout of my field. The pigging consists on sending, and we are going to see a bit now how it looks like, but it's a pig, okay, through the pipe, and it might be done for different reasons. Okay, so you have so you're pushing, remember to send this pig, you are pushing with a high pressure, okay, with a motive fluid. Okay, so that's the moving fluid, okay, that is moving the pig. And usually you either use hydrocarbon, um, or I can use some gas. And here I have color, okay. For example, I have that I might want to send this pig, and that this is the pig, okay. And I want to send the pig through the flow line for different purposes, okay. I might, for example, want to be able to, for example, to make pipeline inspection. Okay, in that case, the pig has some equipment that is sensing the thickness, for example, of the pipe, and is trying to detect if there is damage. There is a reduction of thickness, for example, due to corrosion. Okay, corrosion inspection. Okay, I also need to use that, for example, when I'm doing remove water or liquid accumulated in low points. Okay, for example, okay, remove liquid in lower points, low points, have an S, right? Low points. For example, I want to use a chemical treatment. Okay, and chemical treatment, typically I send, if I have my flow line or my pipeline, I'm between two peaks. I trap the chemical that I want to use to treat the pipe, and then I put it in the in between. Okay, this chemical that I want to use for treating. Hmm. Another reason I want to use pigging, and it's also a very common and very important reason, is simply to make wax scraping. Okay, for example, might have some use color, maybe this one. Okay, I might have scrap deposits or other solid deposits on the wall. Okay, so that I want to remove. So I just pass a pig, wax deposits. Okay. So inspection, remove liquid accumulated. You want to make chemical treatment, a wax scraping. There are many reasons why we sometimes have to send pigs through the system, okay, through the pipe. And you see, I always need a moving fluid that typically can be it's dead oil, okay, or if for example, I'm removing the liquids from a pipe, I'm not going to use liquid, but I use a gas, okay. Okay, I use maybe nitrogen. I can simply use the production fluids. Okay, we are going to see now a few things, how they might work. Okay, so that's pigging, and pigging causes a few problems. How to do pigging causes a few issues in our system. Okay, because if you see, we have to push or be able to pump it. We have here a pump, okay, or a compressor, but we need to be able to push that somehow. So driving pump, okay. These how the pigs look like. We have different types, but we have these which are um, deformable foam pigs. We have some which are disc and stem. We have some others here. You have the inspection pigs, which are quite expensive, and actually they have all the instrumentation needed to check the thickness of the pipe and to inspect the pipe. And that's, for example, with wax scraping, that's what you get at the end, of course, because the wax is starting to accumulate in the front of the pig. And again, it's very critical if you get a big plug of wax, okay, in the front of the pig, then you have to be able to push it further. Okay, otherwise, if you need to increase too much the pressure, then the pipe might burst. Okay, so you have to be always careful with that. Okay, so one thing we use, for example, pigging is used. One of the reasons you use pig in subsea systems, okay, one of the things is that, let me just go back to black. We have our platform, and then we have our main pipe, for example, export pipe, export oil pipe. Making in blue, and then goes to another, for example, platform or buoy for export. Okay, so this will be an oil export pipe. Okay, so in that case, you have the problem that it might accumulate wax in this line with time, okay, due to low temperature. So in this case, you want to peak, send the peak from this end, and then receive it on this other end. Okay, which is not a big problem. Usually, we are going to see a bit later how the launcher looks like. It's a bit like that, launcher. So you insert the peak here, and initially the fluid simply is bypassing, okay, or that's is bypassing here. You have the main. Maybe we should make a small drawing. Okay, maybe using this. Okay, so in here you have one where you insert the pig, one chamber. And here you have quite a lot of valves. Okay, so you put open, this valve has to be closed. So you open here, you insert the pig in this chamber. Okay, you put the pig here. Okay, then you start circulating fluid. In this case, can be dead oil, for example. Then you push, it's circulating through here and reaching the end. And then simply at some point you close this valve, open this valve, and open this valve, and then you start pushing the pig. It enters into the pipe, and then it pushes all the way to the next end. Okay, and in the other end you have something similar. Normally it goes through here. Okay. Normally the liquid goes through here, but at some point when the pig is approaching, and the pig usually has a sensor inside that they detect where it is, so they deviate, make it pass through here, and then they close the two valves. Okay. Going to see a bit later how that works. Okay, but you have here a more schematic, the launcher, how it looks like. You have an opening, you put the pig inside, then you flush the fluid through it. Then you have like a conus structure to insert the pig into the pipe. And then the receiver is something also similar. You have a bypass line, but not the pig goes inside. And it after here it goes into this big chamber. Simply the fluid the bypasses the pig. Okay. And now let me just make another slide. Okay, so then you see, for example, that some cases where I have two lines. Okay, let's go back to our four. Okay, to our four. We have one here and one header here. And if we had these two lines, okay, that go to the platform, and we have the reach separator A and separator B, or the test. Okay, and here we have our well, can either produce to this line or can produce to this line. Okay, so you see that if you have this configuration, you can very easily, if you want to pick this line, okay, you can simply very easy to send the pig from one end, okay, and then you can return it through the other end. But then what you need is to have this valve, okay, this pigging valve or crossover valve, and it has to be fully open, right? And the wells, they have to be, the valves to the wells, they have to be closed. From the wells, they have to be closed. Okay, such that in this case you can peek from this side, do inspection, do whatever you need to do, wax scraping, anything, and then you return through this line. Okay. You can also have the same configuration if you have, for example, several. If pigging is an issue in your field, you have to make frequent pigging. Okay, then you have, okay, then you have two templates. You have your wells here, or they can go to this manifold. Okay, also the same thing here. Remember, the well is a part of the template. In this case, you can also have subsea uh, satellite wells, but in this case, the main pipe is exactly the same, and it can go through many templates at the same time. And here is where you have your crossover valve. Okay, here you have the two separators. Okay. And let's make just a comment here that this is we are saying here that this is on the platform. Okay, and you see there that valve, that now you see the purpose of that pigging loop isolation valve simply is to allow to open for the pig to pass. Then remember also that when you send the pig, the pipe size usually is the same, and the valves here, they have to be open bore. Okay, the same valves that we mentioned here, full bore. That means that when they open, they simply are uninterrupted diameter from here to here. Okay. Because that's needed. There have been some attempts to use peaks that they have a change in size. For example, you can use two lines with different diameter, but they are not that they fold somehow when they enter, they change the cross section of the pipe, but they haven't been that successful. Okay, here we have a video, okay, of pigging. That's on-land pigging. Can you see the pig launcher? So you open, or lowering the pig. Okay, you insert it in the pig launcher. Okay, now you open that valve and you pressurize behind that. Of course, we cannot do that onshore unless we have a motive fluid, which is not hydrocarbon. And then start to push it. Okay, in this case is measuring the integrity of the pipe, measuring if there are any corrosion spots. Then when you receive it, exactly the same thing. When you feel that the pig is approaching, then you open and you close it, bypass. Now you have to go through the pig launcher. Okay, and after that you can simply again bypass and return to normal operation. Okay, before we go leaf pigging, I just okay, let's have one more comment here. That sometimes pigging can also be done offshore pig launcher. Okay. where you have on your you have a peak launcher, you have a module where you can connect if you have just one, let's say one header and then you have one pipe. Okay, you can simply connect here, come with a vessel, okay, and you can insert the peak. If the main line, for example in the Snövit, which the main line transportation line was too long and you don't want to put two, you need just one, so then you put like an offshore, okay, offshore, or it will be a subsea peak launcher. Okay. Subsea peak launcher. Okay. Okay, in which you have either the launcher is, you have just the port in which you insert the peak and then the launcher is here, or you have the peak launcher and you have like a magazine of peaks inside. So you release peaks every with certain frequency. Okay, but typically you come with a vessel where you insert the pig in the system and then the pig is actually moved with production fluid. Okay, pig is usually driven with production fluid behind. Okay. So a summary table about our discussion. If we are in deep water, more than 1700 meters, then we have to go wet Christmas trees. We have to use subsea wells. There are no other options. For all the rest, we can use dry or wet. Okay, if the reservoir is spread or we have multiple reservoir units, we usually use subsea wells. If we need frequent well intervention, it is desirable to use dry Christmas trees or platform wells because then we have access to the well whenever we want. If we have flow assurance concerns, that means we might have some pressure and temperature reduction too much on the commingling, on the commingling system, on the flow line and pipeline, then we can have these issues with wax, hydrate, scaling. So then we usually like to have dry Christmas trees. If we have plans for infill drilling, okay, and we don't know about the size of the reservoir, how much we can produce, usually using having platform wells is useful because you can drill more wells as you need them, but also the space is critical because then you need to maybe make your structure bigger than what actually should be. Okay, so I have put here both because of that. To have the dry Christmas trees is useful because then you can drill, you have the drilling package available to make more infill drilling when needed, but also it's very costly. Okay, so for that case, you might also want to use subsea wells. And progressive production startup, usually wet Christmas trees, subsea wells are what gives you allows you to give a production progressive production startup. Okay, dry Christmas trees, jacket, gravity base structure, usually spar and TLP, but wet Christmas tree subsea wells are usually all. Okay. Here is a case for Mivarosen. You see that they use mainly, they are drilling for this reservoir unit, they're drilling all wells from this jacket, okay, using platform wells. But they have from one unit that was a bit far away, I think a few kilometers away, then they have used subsea wells. Okay. Then we go into the need of oil and condensate storage. When we have a gas field, they usually have to be connected to the gas transportation line, or if they have an LNG. But the liquid, which is very valuable and actually increases, is improving the value of is improving the, giving a lot of value because of the additional revenue. It's if this is usually transported with tanker. Okay, so you need to have some storage because you cannot have, if you cannot have a tanker, the tanker didn't arrive on time, then you will need to hold production because you cannot process any more condensate, okay, or liquid. So in those cases, if you need, for example, you're in a remote area, Hanstein, for example, it's a relatively remote and harsh environment. So they had concerns about if the tanker might be delayed for a few days due to bad weather. So in that case, they needed some to have some storage, such that they don't have to interrupt production with bad weather, because they just have a pipe to transport the gas, but not the condensate. Okay. If that's the case, for example, FPSOs, they can have a big storage, okay, gravity-based structure. They also, I don't think it's that big, but it might be like 500,000, 300,000 barrels, okay. While the ones that don't have any storage, they are the jackets, semi-subs, and TLPs. Spars, the only spar that now has storage is the Ostahansin that has some condensate storage. So before we go into the last point, which is the marine loads on the oceanographic environment, the effect of wind, waves, and current, I just want to say some other selection criteria for offshore structure that we have that are usually taken into account its previous experience, if the company have used that structure previously. Um, then they know how it works, they have experience with it, they know the issues, and they are more willing to use it, or more or not so willing to use it later. Riser issues, there are a lot of issues with the risers in the riser, the pipe. Um, and because each structure you need to hang the riser on on the structure, and then you have different movement of the structure. So if you maybe because of the water depth combination, the number of risers you need to have and the size of the risers, that might be an issue. Then that's going to affect your selection criteria. Topside upgrade flexibility, if you have maybe related to the uncertainty in the subsurface, if you're not sure how much you're going to get, maybe you start with a smaller facility and then you want to have the option to upgrade it depending on how much you have. Um, that depends. The third point, if depending on the demand, how many offshore structures are being manufactured, the workshops they will have different workload. So you might have long waiting times for one type of structure, but not so much for the other structure for other types of structure. Maturity of technology, how many structures are there of that type have been used in the world. And also some other considerations are maintenance and OpEx, which is might be slightly different. Keep and pause.